Larry Scofield is the Director of Pavement Innovation at the American Concrete Pavement Association, as well as Director at International Grooving and Grinding Association. He was the 2008 recipient of the Lester F. Kuzmic Award, the highest honor bestowed by IGGA. Larry is active in TRB and in Federal Highways Pavement Preservation Technical Feedback Group. Larry Scofield will discuss pavement preservation treatments for concrete pavement.
Thank you, John, and good morning and afternoon, everybody. Again, this is the pavement preservation basics, and after my other brother Larry did a great job, I hope I can do the same on the concrete treatment side. So I'm going to take a little bit different tack than probably what most of you are expecting, because I'm long of tooth, so I'm going to try and bring things forward where concrete's different. And instead of giving you an outline of my presentation, I'm going to start with the takeaway messages. And I think these are the most important things probably in my presentation, that concrete pavements perform differently than flexible pavements. And we'll get into that a lot more. Concrete pavement preservation begins with the design. We focus on the repairs and not on the prevention. And what I'm trying to do in this presentation is bring back awareness to, we need to worry about the beginning side of it as well. And then it ought to be performance-based preservation. And what that means is we have a very strong data-rich environment. And I'll show you some examples of that hopefully later on. So the table here shows you what would typically be considered the concrete pavement preservation activities: the diamond grinding or diamond grooving, partial depth or full depth repair, dowel bar retrofit, joint sealing or resealing, slab jacking, stabilization, longitudinal crack stitching, and buried treasure. And buried treasure is one of the more recent ones, and what that does is if you had a concrete pavement that was overlaid for functional reasons, you can remove the AC and then go back and restore it today. So you'll also notice the 4 smiley faces. What those represent are the sessions that will be in session 5 that cover those in detail. I'm not going to go into detail on these because, like I said, I'm trying to focus more on the beginning of pavement preservation. So again, I'm going to walk you back through time a little bit, and you can see the ASHO road test up there. And one of the things that we've always struggled with, all of us, is how to define pavement performance. And the ASHO road test was the same way, and 2 gentlemen by the name of Kerry and Irick came up with a serviceability concept. And what they did is they said, well, the engineers all disagree on how to define pavement performance. And essentially, we don't really care what the engineers think. Let's go out and look at what the consumer thinks. So they came up with a method to relate objective measurements to subjective ratings, i.e. the consumer. And so that was a groundbreaker, and that sticks with us today. You could argue this may be the first composite statistic that was evolved. If you look at the red box, what that's showing you is how they did that, and what that would be known today as a cumulative distribution plot. I'm going to show you some of that later on, but understand this is the 1950s when things were done by hand. So there's no real excuse when we have computers and all that kind of technology, but they actually use that data analysis technique. Not long after the ASHO road test is when people started throwing around the idea of pavement management, began in the 1960s. If you look at the top right-hand corner, you know, that's, many of us old timers think the Bible by Dr. Haas and Hudson is really where it all started. And you can see the first edition is 78. It was reprinted in 82, and I'm going to be able to show you some information out of that. The thing I want to point out, if you look at the 3rd bullet on the lower right-hand corner, the first state that executed a working pavement management system was Washington DOT. So I want to give them a lot of shout outs and accolades, and then I'm going to show you some data and why this is important. If you look at the 1982 book, you'll see a step staircase chart like this. The text that you see on each of those steps is from that. The graphics below that were put in by me to kind of relate how we are today. But again, this is 1982, and what they envisioned, the first thing would be computerized existing models. If you remember back, agencies didn't have PCs at that time. Everything was mainframe based or mini computer, and access to computer time was a lot more difficult. They thought the next improvement would be through models through research and implementation, and then getting into probabilistic type modeling. I put that graph in there because what you see is from a bimodal distribution where you have early failures to where your normal population is the bigger one, but notice the dashed line indicates we've controlled the variability. And that's really what all this should be focused towards. And then the real game changer was the mechanistic models, and one could argue Pavement ME has got us there. And then there's a couple other steps and undefined, and the question is the 3D automated data collection. Lauren did a fantastic job. I've been out of the agency side for a long time, and that was so exciting. It makes me want to get back into it. And you got traffic speed deflectometers. So there's lots of improvements that have been made over time. So one of the big concepts of the Hudson Haas Pavement Management book was called the closed feedback loop. And I'm really emphasizing this because I think we've really forgotten that in modern times. We get so caught up in how to fix it, we forget that maybe we should do things that we don't have to fix it. And so I took theirs, and I spent too much time watching The Lion King, so I call this the circle of life. But if you look down here, your pavement preservation for concrete pavement should really begin in design. Get back to material specification, construction, and then your environment, traffic, and maintenance, and even your performance monitoring and evaluation. You may think that this aspect of it doesn't impact it, but the accuracy and repeatability of these kind of equipment actually impact what you may determine as performance. So as we get more and more capability in the future, as we clearly are getting, then that should all improve. So this is a traditional portrayal of pavement performance, and my argument is this is really based on AC performance, and quite frankly it should be, because that's most of the network. And so how we define it is we come in here at some intervention point and come down here, and then we call this the additional life. I would argue that concrete pavement really doesn't perform that way, and we ought to be thinking of concrete pavement in a different manner than what we do AC pavement. They're both right, but they're different. And this is showing you up in the upper right-hand corner some LTPP data for roughness, and you'll notice those are pretty much horizontal. So just to kind of reinforce that, our goal should always be that concrete pavements outlast the generation that builds them. And I think that's very, very realistic, and I'm going to show you some data to support that. This is the oldest concrete street in the United States, and look at its age. If it was not a historic street, it wouldn't be there. We all know that. But the point is, they're not going out there every year and doing things to it, and we ought to be thinking of how best to make it last a long time. Again, this is the traditional form, and then we came along and we put categories, and these were really based on funding boxes, and pavements don't really care about funding boxes. I know agencies have to, that's what we all live with, but the problem I have, would this one fall in the preservation side, or would this fall in the reconstruction side? So what I'm trying to get when I say you need to think differently about concrete pavements, what about early repair of construction defects? That really doesn't get done until we get out in this range. And in reality, maybe we ought to be doing that sooner, and maybe it would last longer. I also think you need to manage individual distresses and not composite statistics. Again, the Asheville Road test is where the first composite statistics came from, and it was alive and well. This is a graph from Dr. Darter. This is vintage 1990s, mid-1990s, I believe, and I believe this was probably the 93 ASHO design. What you have on the horizontal axis is different states and the routes that they did the evaluation on. This is easels on the left-hand side. Sorry for not putting it on there. And what you're seeing in the dark blue is actually the design easels for that project. The green columns are actually showing the number of easels they had at the time they did the diamond grinding, and then at the time of the study, the total easels on that project since construction. So you can see, except for the Florida project, every other one of these projects, they didn't even do the preservation or the diamond grinding until after it already exceeded the design life. And this is how historically a lot of concrete pavements have been managed. And the question is, if we got in on them sooner, would it even be lasting longer than what it is? This is a more recent evaluation by Dr. Darter. This is Utah. Again, this is a different form of a cumulative distribution plot called a survival curve. So this is showing you the age again, and then the concrete. And again, all this is portraying is they perform differently, and that's needs to be recognized in how you manage them. The other thing we tend to do as civil engineers, at least in my opinion, is one size fits all. We say they all need to be doweled and how many dowels, or they all need to be sealed or not sealed or tied. And we really need to be thinking more about each of the specific applications. And so on the left-hand side, what I'm trying to do is reinforce some of the ideas of what happens in a pavement management system and how it relates back to concrete. So pavement management is a lagging system, as everybody's probably aware of. So what that means in terms of concrete pavements is it has to break before you even know there's an issue. And that may not be the best way to manage concrete pavements. Unfortunately, a lot of the pavement management systems do not really, they have certain thresholds before there has to be so much damage before they even bother with a project, because they typically do last longer than design. They also know they can get away without doing it. And so I think we've gotten to the point that we go too far out on the concrete pavements before we go in and do the strategies. And again, I think it's more appropriate to manage the individual performance factors and not use composite index. And then at the last one down there, as I mentioned, you've actually got probably a large number of agencies don't even include concrete pavements in their pavement management system, and that we just need to get away from that. Some of the thoughts as far as concrete pavements, cracking may not become visible for up to 2 years after new construction. So again, you wouldn't know that there was a construction defect until you're down the road. So maybe one of the things to think about is going in earlier and looking for these things and seeing if you shouldn't correct them at that time. And then would the pavement last even longer? Same way with curl and warp and joint opening widths, they're going to change after construction. And then the treatment life versus pavement life has been the proverbial argument forever. We're not there yet, but one of the things on concrete pavement you should be doing or thinking and striving for concrete treatments that last as long as the rest of the remaining life of the pavement. Most people, the 10-year life is what is always thrown out, but most people really don't define how much life do you want to get back out of this pavement. But the treatment that you repair it with should last that length of time. So what's different today? This is a little chart on my life, but you can see the human was thin and the technology was thick. And then as I got older, I got thicker and the technology got better. I think Lauren did a fantastic job of showing just how technology has changed over time. But just like me in this picture, pavements change in time also. And for example, concrete pavement actually increases in strength over time, yet I'm not aware of any state that considers that in their pavement preservation program. So just to remind you where we came from, this is the ASHO road test. This is a proverbial crack map, and this is a real one. But when you look at today, you can actually have it done. And instead of, you're actually looking to graph, but you can also do distributions of crack widths. If you go back to the beginning of pavement management in the early 60s, this is what the NASA command center looked like when President Kennedy challenged them to put a man on the moon. If you'll notice, there's not a single monitor in that room. And also look at the gigabytes. And Lauren's slide made this one look, like I said, old time itself, but this is how much technology is making. Instead of doing sampling on systems, we need to start getting back into 100% coverage and those kind of things. It's all possible. So again, what I'm trying to reinforce is this circle of life. Pavement ME is probably the game changer as far as I'm concerned on the concrete pavement side, because now you can predict the distresses at being roughness, transverse and longitudinal cracking, faulting, and spalling. So now I can start out here in the design and I can say exactly what's going to happen based on actual construction materials, my specifications and process, and everything that counts. And if it should track along, if my design's any good and all these are good, then it should track. If not, then we need to feed back to the beginning of what's wrong and fix it. This is something we have not been able to do in the beginning, and now we can actually do it on construction projects, or excuse me, construction properties, and do it cradle to grave. We don't have to use nominal values for all pavements. This is showing you some LTPP SPS2 data. In this lower left curve, the blue curves actually represent measured or observed performance, and then the yellow brown is actually the predicted. So this is what I would call a well-behaved curve. And in the upper right up here, I would call this a not so well-behaved curve. And my point is, if we have something like this, so my measured is telling me there's nothing going on, but my predicted said this thing's going in the toilet very quickly. And so at some point in here, I don't have to wait till something breaks. I can say something's not right. And it may be the design inputs were wrong. It may be there's materials issues, construction materials. Maybe I need to tweak the design software itself. But this is the goal that we should all strive for, where we can compare the predicted to the observed, and then know when to go in and do something. This was a survey done in 2016. Again, I'll just remind you, the pavement ME was faulting, roughness, and then cracking. This shows you the yellow states, or the states that responded to that survey, and this is showing you what distresses they're actually using for intervention points, and you can see the legend over here. And there's a number of things observed there. Many of them are quite different, and there's more than what you could actually predict. But when you see the M, that's many, so it could be almost all of these. So it is a complex problem. But again, I'm going to advocate that we ought to be looking at individual distresses. This was another survey done in 2017. It was one of the same projects. When the top 10 that John was talking about earlier today, the blue states represent how many were responded. And this is showing you the triggers that the different states use. And I suspect that's really hard to read. And it's okay, I'm just trying to show you the ones we got. But what's really important in this slide is this concept of lag between data collection, analysis, and actual treatment. I tried to show you in the first Darter slide where they weren't even applying the applications till after the design life of the project. So if you take that approach and then realize it may be between 2 and 5 years from when you first or last got the data and analysis to when you actually applied the treatment, you're going way past the window of opportunity. And that's, again, I think these are things that we need to start remembering and getting back on. The other thing I want to mention is a data-rich environment. And this gets back to what previous speakers were talking about. Again, this is hats off to Washington DOT. Each of these columns represents a different project. And this is pavement age in years. And the green portion of these represents the original concrete pavement life before they did dowel bar retrofit. And then the gray portion represents how long it's lasted since the dowel bar retrofits were installed. Now, a couple things to notice. This is 40 years, and look how many pavements they have over 40 years. The other thing to note is this is an old slide. All of these bars could be extended another 30 years. But look at the age of some of these. These aren't historic pavements. A number of these are on I-90 in Washington. But this is the importance of a data-rich environment, and where we can predict and compare that to observed. Here's another Washington slide. And again, at the bottom, they're showing you different age categories. And then they're showing you the lane miles within each of those categories. And then for this age category, they're showing you the different treatments that you can see over here that they've applied, what % of each. And this is what you can do when you have a very good pavement management system. And this is where I think we need a greater emphasis on pavement preservation. We focused an awful lot on how to do things. And quite frankly, most of the pavement preservation techniques haven't changed a great deal over the last number of years. But we've kind of forgot that we don't have to necessarily be repairing things. And so what I'm hoping to do is get more emphasis on that. This is a cumulative distribution plot. I showed you the serviceability concept. This is a modern application of that same technology and how I think data should be looked at. This compares actually 2 different surveys, one done by NC Squared and one by the FHWA ETG. Quite frankly, I was actually amazed at how closely these 2 surveys overlapped. I'm not a fan of surveys because I think they oftentimes can be misleading. But with a cumulative distribution plot, you can figure out what % of your data meets a certain threshold. So if everyone else is saying the mean is 12 years and your agency, your mean is down here at 4 years, you ought to be looking at your agencies. But for this particular treatment, you can notice the blue things are the states that responded. Look at the ranges of some of them. Those are very large ranges. So I think using the mean of this data, for example, 5 for this one, can be misleading in this cumulative distribution plot. And so this is why we need to, like I said, get really good data and have very good tracking mechanisms. One of the other things I'll mention, this is a project from Douglas County, Colorado. They were doing a diamond grinding for 500,000 square yards, and their pavements range from very good condition to not so good condition. And you can see they had different roughness levels. And where you saw the 300 to 400 inches per mile, that was a 7-inch thick concrete pavement placed on clay subgrade and had 1-inch faulting. So if you wanted to reduce that faulting, you had to make the pavement much thinner. So instead of just doing a one-size-fits-all, they actually came up with a different roughness spec for each of these areas. And I thought this was really good engineering, and I think they're one of the few agencies that I've seen do this. Most agencies have one-size-fits-all smoothness, and I think you need to, as an owner, need to consider whether that's the best approach or not. So for references, Concrete Pavement Preservation Guide on the left. This is the best resource. This is the 2nd edition. The 3rd edition is done. I haven't seen it published, so I couldn't put a picture of it. And you get that from the CP Tech Center. And then if you want to learn more about concrete pavement distress assessments and solutions, this is also a very extensive document. There's also FHWA contractor training, sponsored contractor training through NHI. And as far as I'm concerned, that may be some of the best training that's done today or available today. So if you want to look at it, you sign up for the NHI courses. So in summary, again, what I'm invoking here is cradle to grave management preservation. I see those as one and the same. And again, I'm reinforcing the circle of life, the original themes. We need to manage individual stresses for long life pavements. We don't want to just keep running them in the ground and then going out and fixing them. The question is, if you fix them earlier, how much longer would they last? And it begins with a design. We need to worry more about not letting it happen instead of just how to fix it. And I think we've lost that in the modern times. And then performance-based preservation, data-rich environment. We ought to be able to have a prediction and then compare it to the observed. So with that, I'll conclude and thank you very much, and thank everybody for participating. And my thing that I always throw out there is, remember, we're the ones who put a man on the moon or a person on the moon. We can do whatever we strive to accomplish. So thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.